Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's lesson, we'll be talking about the periodic table, and under this periodic table, we'll be talking about the history of the periodic table, how the periodic table came into an existence, and we'll be talking about the modern periodic law, and we'll also be talking about the groups and period of the periodic table, and we'll be talking about the trends of the periodic table, and lastly we'll be talking about the characteristics of metals, non-metals and metalloids in the periodic table. So stick with me till the end and let's enjoy the best out of the lesson. So firstly, let's talk about the history of the periodic table as shown on the board. So before the history of the periodic table, let's define the periodic table. So by definition, the periodic table can be defined as the organized arrangement of elements according to their atomic number. So this is a simple definition of the periodic table. We can define the periodic table as the organized arrangement of elements according to their increasing atomic number. So this is a simple definition of the periodic table. And since we have defined the periodic table, let's look at how the periodic table came into an existence. So looking at this, we'll be talking about the key historical milestone of the periodic table. So let's talk about the key historical milestone of the periodic table. So when we talk about the key historical milestone of the periodic table, we'll be talking about two icons in this aspect, and one of the icon is Dmitry Mendeleev. So we'll be talking about the Dmitry Mendeleev in 1869. So what is the contribution of Dmitry Mendeleev to the periodic table? So one of the contribution is that he is recognized as the father of the modern periodic table. So this is one of the contribution of Dmitry Mendeleev to the periodic table. So he is recognized as the father of the modern periodic table. So another contribution of Dmitry Mendeleev is that he arranged the periodic table as increasing atomic mass. So this is another contribution of Dmitry Mendeleev to the periodic table. You can see from the definition of the periodic table, we said it is the arrangement of an element according to their increasing atomic number. But Dmitry Mendeleev defined periodic table according to their increasing atomic mass. So he is recognized as the father of the modern periodic table, and he also arranged the periodic table as increasing atomic mass. So these are the two most recognized contribution of Dmitry Mendeleev. So another icon that we'll be talking about is Harry Mosley in 1913. So part of Harry Mosley's contribution, he discovered that the periodic table is arranged by increasing atomic number and not atomic mass. So you can see the difference between Harry Mosley contribution and Dmitry Mendeleev contribution. You can see on Dmitry Mendeleev contribution, he arranged the periodic table according to their increasing atomic mass. But Henry Mosley, he discovered that the periodic table is arranged by increasing atomic number and not atomic mass. He arranged the periodic table according to their atomic number. So this is the major contribution of the two icons that we'll be looking about. So we are talking about Dmitry Mendeleev, is the father of the modern periodic table, and he arranged the periodic table as increasing atomic mass. And Henry Mosley in 1913, he discovered that the periodic table is arranged according to their increasing atomic number and not atomic mass. So his contribution counter what Dmitry Mendeleev discovered. And in that later he arranged the periodic table according to their increasing atomic number. So this will be all about the history of the periodic table. And lastly, we'll be looking at the modern periodic law. So looking at the modern periodic law states that So let's write the modern periodic law here. So this is the modern periodic law. So the modern periodic law states that the physical and chemical properties of elements are the periodic function of their atomic number. So this is what the modern periodic law is all about. So the modern periodic law is telling us that the physical and the chemical properties of elements are the periodic function of their atomic number. So that means that any element that you see, the physical properties and the chemical properties of that element is determined by their element's atomic number. And this is what the modern periodic law is trying to tell us about. So this will be all about the history of the periodic table. So under this, let's look at some questions under this aspect. So the first question as displayed on the screen says that who is considered as the father of the modern periodic table? A. Newlands, B. Moseley, C. Mendeleev, and D. Dobrynin. So the correct answer to this question, you can say that Mendeleev is the father of the modern periodic table according to what we said earlier under Mendeleev's contribution. So Mendeleev is correct to this kind of question. So option C is correct. And the second question we have says that the modern periodic table is arranged based on what? A. Atomic mass, B. Density, C. Atomic number, and D. Neutron number. So from what we said, the modern periodic table, you can see that the modern periodic table is arranged based on the function of the atomic number. So atomic number is correct to this kind of question. You can see this under Henry Moseley contribution, which he said he arranged the periodic table according to their increased atomic number. So the modern periodic table is arranged based on their increasing atomic number. So option C is correct to this kind of question. And that will be all on the history of the periodic table. So let's move to the groups and periods of the periodic table. So moving to the groups and periods of the periodic table is arranged. So let me write this down. The periodic table is arranged in 18 groups. So let's write the 18 groups. So the 18 groups are on the vertical row, vertical column, yes, they are on the vertical column, and 7 periods, which they are on the horizontal row. So this is a way the periodic table is arranged. So the periodic table is arranged in 18 groups, which are on the vertical column, and 7 periods, which are on the horizontal column. So looking at this, let's look at the groups and periods one by one. So as shown on the screen, you can see we have the groups. You can see the group 1 to 18 as shown on the screen. So under this group, we have the group 1. So those group 1, they are known as group 1A. So you can see the 1A. So under this group 1, they are called the alkali metal. And example of this group 1 is we have sodium, we have lithium, and we have potassium and so on. So these are group 1 elements. They are known as alkali metal, and we have example like sodium, lithium, and potassium as shown on the screen. You can see the group 1 rules. And another group that we have is the group 2. So we have the group 2. So they are known as the group 2A. So these are the group 2A, and they are known as what? The alkali earth metals. So group 2A are called alkali earth metals. And examples are what? We have beryllium, magnesium, and so on. So these are group 2 elements. So group 1 elements, they form plus 1 ion. So group 1 elements form plus 1 ion, which means they can only give out one of their electron in that group. And group 2 elements, they have plus 2 ion. So that means they can give out 2 electrons in that element. So moving to another group, we have the group 3 to 12. So this group 3 to 12, they are known as the group 3B. So you can see in this group 3 to 12, what you can find here are the transition metals. So we have the transition metals. So in these transition metals, example of these transition metals are scandium, and we have titanium, and so on. So what does this group 3B do? You can see that from what we know, we already know that we have group 8. This is what they taught us. We have group 8. But from the periodic table, we are having group 18. So under this group 18, we have the group 1, group 2, group 3 to 12. So those group 3 to 12 are known as the transition metals and they are called the group 3b. So you can see if we still write this finish, we are still going to have 8 groups. But this is just an advanced group, which is the group 3 to 12, and they are known as group 3b. And you can see they contain transition metals as shown in the diagram. So these transition metals, they possess variable oxidation states. So they have variable oxidation states, which means they can have +1, +2, +3, +4, and so on. So these are what the transition metals do. And in another group, we have the group 13. So after group 12, we have the group 13. So this group 13 are known as the group 3A. You can see we have the group 1, group 2, group 3 to 12, which is the group 3B, which are known as the transition metals. And we have the group 13 on the other hand, which is known as the group 3A. And this group 13 are known as the boron family. So we can call them the boron family. And looking at this example of this group 13A are known as the boron, aluminium, and so on. So these are examples of group 13, which are known as the group 3A, and they possess +3 ions, which means they can give out 3 ions from their electron. And another group that we have is known as the group 14. So this group 14 are known as the group 4A. And what does this group 14? They are called what? They are called the carbon family. So this group 14 are called the carbon family. You can see them on the screen. And examples of elements on this group 14 or group 4A is known as carbon and silicon. So we have carbon and silicon. So this group, they are known as the carbon family. And another group that we have is known as the group 15. So you can see we have group 15. So this group 15 are known as the group 5A. And what are they called? They are called nitrogens. So this group 15 are called nitrogens. And examples of this group are what? They are nitrogen and phosphorus. So these are what group 15 or group 5A are called. They are called nitrogens and examples are nitrogen and phosphorus. So what they do is that they form -3 ions. That means they collect 3 ions from other elements. They don't give out their 5, they collect 3. So this is what the -3 ion is telling us about. And we also have the group 16, also known as the group 6A. And they are called what? They are called chalcogens. And examples of elements under this group are oxygen, and we have sulfur. So these are examples of elements under the group 16A, which is called chalcogens. They are known as chalcogens, and they form -2 ions. So they form -2 ions, which means they collect 2 ions from other elements. And another group that we have is known as the group 17. So this group 17 are called the group 7A, and they are known as halogens. So this is the name given to the group 7A, which is the group 17. So they are called halogens. And examples of elements under this group is fluorine. We have the likes of fluorine, bromine, iodine, astatine, and so on. And another group that we have, which is the last group, which is the group 18. So we have the group 18, and they are called the group 8A. And the name given to this group is known as the noble gas. They are called noble gas, rare gas, inert gas, as shown on the screen. And examples of elements under this group are helium, neon, and so on. So this group, they don't collect any ion because they have complete their octet configuration. They are filled, their orbitals are filled. So they don't give out, they don't collect. So this is why they call them inert gas. So group 7A, on the other hand, they collect -1 ion, which means they can take 1 ion from other elements. So this is what the group contain. You can see we are still having group 8 because when you look at it, we have the group 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. So you can see we are still having the same 8 groups. But the reason why we are having group 18 on the periodic table is because of the transition metals, which you can find them on the group 3 to 12 on the periodic table. And they are called group 3B. You can see them in this diagram. You can see everything we are saying is on this diagram. So this is all about the groups of the periodic table. So moving on, we have the group 1 and 2, which they are known as the X block. So this group 1 and 2 are known as the X block. And we have the group 3, which are known as the D block. So transition metals are D block. So anything transition metals, they contain the D block. And group 13 to group 18, which is known as the P block. So they are the P block. So group 1 and 2 are known as the S block. Group 3 to 12, which are the transition metals, are known as the D block. And lastly, group 13 to 18 are known as the P block. So let's look at some characteristics of members in the same groups. So looking at the characteristics of members in the same group, you can say one, they have the same number of valence electrons. So what does this mean? This means that any member of a particular group, they must have the same number of valence electrons, which means the number that will be handing their electron must be the same. So let's take group 1 for example. We have sodium in group 1 with a electronic configuration of 281. You can see sodium has an atomic number of 11, and that is why we are having the configuration as 281. So the shell that sodium have is K, L, and M shell. So these are the shell of sodium. You can see we are having 281. So you can see this one is the last number on sodium atom. So let's take another element for example, still in group 1. Let's take potassium for example. You can see potassium is having an atomic number of 19, and the shell configuration will be given as 2881. You can see potassium is having the K, L, M, and N shell. So looking at this potassium and sodium, you can see they are having the same number of valence electrons, which is 1, 1. You can see one is ending the number of sodium atom, and one is also ending the number of potassium atom. So you can see this one, and this is a way you can easily identify the group of an element. You can see one is ending sodium, one is also ending potassium. So you can say sodium is in group 1 and potassium is also in group 1. So this is a way you can determine the group number of a particular element. Let's take another group as an example. Let's take, for example, we have magnesium in group 2. So magnesium is having an atomic number of 12, and the configuration of magnesium will be given as 282 because the atomic number is 12. So if you add this configuration together, you get 12. So you can see magnesium is having the K, L, and the M shell. So you can see what end the number of atom of a magnesium is 2. So you can see magnesium is in group 2 because what is ending it is 2. So let's look at another element in group 2. So let's take beryllium for example. Beryllium is having a atomic number of 4. So the configuration will be 2, 2. So you can see it is having the K and the M shell, L shell. You can see 2 is also ending the atom number of beryllium. So beryllium is having 2, magnesium is also having 2. So you can say they have the same number of valence electrons, which is 2, 2. And also for group 1, they are having 1, 1. So you can say magnesium is in group 2 and also beryllium is in group 2 because the valence electron is 2 and also the valence electron of beryllium is 2. So this is a way you can determine the number of group of a particular element. So if you do all of this for each group, you see they will be having the same number of valence electrons. And this is what this first point is telling us about. And another properties that we have is that they have similar chemical properties. And also, lastly, they have similar bonding pattern. So what these 2 points is telling us about is that elements in the same group will be having a similar chemical properties, which means the chemical properties of sodium is also the same as the chemical properties of potassium in group 1. And also in group 2, the chemical properties of magnesium is also the same as the chemical properties of beryllium. So this is what these similar chemical properties is telling us about. And lastly, we said they have the same or similar bonding pattern. So what this is telling us is that group 1 elements, according to what I said earlier, they will give out one ion, which is the plus 1. So this one, they can easily give this one out, and potassium can also easily give this one out. So they give out the same number of electrons. So they can give out 1 to reach the octet configuration to be 28, and also if it give out 1, it will reach 288, which is the octet configuration. And also in group 2, magnesium for example, it can give out 2 electrons, which is the plus 2 ion that I put here. So also beryllium can also give out 2 electrons. And this is what this similar bonding pattern is telling us about. So when we get to bonding, we talk more about this because when they give out 1 electron and 1 electron, we can say this is known as the ionic bonding pattern because they can easily give out 1 electron each. And you can see for group 2, it can give out 2 electrons, and also beryllium can give out 2 electrons. So this is what the similar bonding pattern is telling us about, and this will be all about the groups of the periodic table. So now let's move to the periods of the periodic table. So moving to the periods of the periodic table, so let's write the period. We say we have the period 1 to 7, and they are on the horizontal row. So these are the period arrangements in the periodic table. So under this, we can say the characteristics of elements in the same period. You can say their atomic number increases from left to right, and we can also say that the period number is equal to the shell number. So what does this mean? This means that elements in the same period, their atomic number increases from left to right, and the period number is also equal to the shell number. So what does this period number equal to the shell number means? As said earlier, we said sodium is in group 1, so we can say the atomic number of sodium is 11. Let's assume that we don't know the group and the period of sodium, and we know that the atomic number of sodium is 11. So how can we determine the number of period and the group number of sodium? So knowing that the atomic number of sodium is 11, and we can write the shell as 281. So you can see the number of shell in sodium is, we have the K, L, and M shell as said earlier. So now how can we determine the number of group and the number of period of sodium? Let's assume that we only know the atomic number of sodium, and we want to use it to determine the number of group and the number of period of sodium. So from what we said earlier, we said that the last number is always their group number. So we can say sodium belongs to group 1. So we can get the group by looking at the valence electron. So we can say sodium belongs to group 1. So now, how can we know the number of period? So we said that the period number is also equal to the shell number. So we can just count the shell number, which is 1, 2, 3. So we can say sodium belongs to group 1 and period 3. So this is a way we can easily determine the number of group and the number of period of a particular element. So let's look at another element, for example. So let's look at potassium, for example. So let's assume we don't know the group number and the period number of potassium. So we only know the atomic number of potassium to be 19. So now that we know the atomic number of potassium to be 19, we can easily write the shell configuration, which is 2881. So now, to determine the number, so let's number this shell. We have the K, L, N, N shell. So now, to determine the number of group of potassium, we can easily know the last number, which is the last valence electron. So we can say potassium belongs to group 1 because we already get the last number, which is the valence electron, to be group 1. And to determine the number of period of potassium, we said that the period number is also equal to the shell number. So we can just easily count the shell, which is 1, 2, 3, 4. So we can say potassium belongs to group 1 and period 4. So this is a way we can easily get the group number and the period number of a particular element. Let's look at another element. For example, let's look at magnesium. So how can we determine the group number and the period number of magnesium, assuming that we only know the atomic number of magnesium? So the atomic number of magnesium is 12. So we can easily write the shell configuration as 282. So now that we know the shell configuration of the magnesium atom using the atomic number, we can say the shell are the K, L, and the M shell. So now, how can we determine the group number? We can just look at the last valence electron, which is 2 in this case. So we can say magnesium belongs to group 2. And to know the number of period, we said the period number is also equal to the shell number. So we can just count the shell number, which is 1, 2, 3. So we can say magnesium belongs to group 2 and period 3. So you can do this for any element you want. So far you know the atomic number of that element, you can easily get the group number and the period number of that particular element. So this will be all about the groups and period of the periodic table. So let's look at some questions under this aspect. So question 1 as displayed on the screen says that elements in the same group have the same A atomic mass, B number of valence electrons, C number of neutrons, and D atomic radius. So looking at this option, we said the elements in the same group have the same number of valence electrons. If you write that down, you will see B is correct to this kind of question. So elements in the same group have the same number of valence electrons. So you can see for group 1, they are having the same number of valence electrons, which is 1, and also 1 for another group 1 element, which is potassium. So you can say option B is correct to this kind of question. So elements in the same group have the same number of valence electrons. And another question that we have says that group 18 elements are known as what? A halogen, B noble gas, C metals, and D metalloids. So for this kind of question, we say group 18 elements are also known as noble gas, rare gas, or inert gas. So any of this answer is correct. So looking at this question, option B is correct, which is known as noble gas. And to the last question we have under this aspect, the question says period number corresponds to what? A neutron shell, B electron shell, C number of isotopes, and D atomic radius. So looking at this question, we said that the period number is also equal to the what? To shell number. So we can say period number corresponds to the electron shells. So option B is correct to this kind of question. And that will be all on the groups and periods of the periodic table. So now let's move to the trends of the periodic table. So moving to the trends on the periodic table, the common trends are we have the atomic radius, and we have the electropositivity, we also have the ionization energy, and we have the electron affinity, and lastly we have the electronegativity. So these are the common trends of the periodic table. We have other trends like the reactivity, metallic character, and so on and so forth like that. But these are the major or the common trends of the periodic table. And these are where most questions are always coming out on the periodic table. So we have the atomic radius, the electropositivity, ionization energy, electron affinity, and electronegativity. So before we move to their trends, let's define all of these one by one. So let's define the atomic radius. So we have the atomic radius, and this is defined as the distance between the nucleus and the outermost electron shell. So this is the definition of the atomic radius. The atomic radius is the distance between the nucleus and the outermost electron shell. So let's say we have the atom. So let's say this is the atom, and we have another atom, and we have another shell rather. So let's say this is the nucleus. So under the atomic structure, from what we discussed on the atomic structure, we said the nucleus contains what? The proton and the neutron. So the distance between this nucleus and the outermost electron shell is known as the atomic radius. So this is the atomic radius. This distance is the atomic radius. So the distance between the nucleus and the outermost electron shell is known as the atomic radius. And this is the definition of the atomic radius. So let's look at the definition of electropositivity. So electropositivity is defined as This is the tendency of an element or an atom to lose an ion to form a cation. So this is the definition of electropositivity. It is the tendency of an element to lose an ion to form a cation. So electropositivity, when an element have a plus one, you can say the element has undergone electropositivity because this plus one means the element has given out one electron. So the tendency of the element to lose an ion to form a cation is known as electropositivity. So another definition that we have is ionization energy. So we have the ionization energy. So ionization energy is the energy required to remove an electron from a gaseous atom. So this is the definition of ionization energy. Ionization energy is the energy required to remove an electron from a gaseous atom. And to the fourth one, we have the electron affinity. So by definition, electron affinity is the energy released when an atom gains an electron. So this is the definition of electron affinity. Electron affinity is the energy released when an atom gains an electron. And lastly, we have the electronegativity. So electronegativity, so by definition, electronegativity is the tendency of an element or an atom to gain an electron to form an anion. So this is the definition of electronegativity. So you can see electropositivity is the tendency of an element to lose an ion to form a cation. But electronegativity is the tendency of an element or an atom to gain an electron to form an anion. So these are the definition of the major traits on the periodic table. So let's look at their traits. So looking at their traits, taking these two first. So atomic radius and electropositivity, they increase down the group and decrease across the period. So these two, atomic radius and electropositivity, they increase down the group and decrease across the period. This trend is important because these are where questions majorly come out on the periodic table. So just know that the atomic radius and the electropositivity increase down the group and decrease across the period. And this theory, ionization energy, electron affinity, and electronegativity, they decrease down the group and increase across the period. So these are the trends of the major trends of the periodic table. So atomic radius and electropositivity, they increase down the group and decrease across the period. So you can say atomic radius increase down the group and also atomic radius decrease across the period. And you can also say electropositivity increase down the group and also electropositivity decrease across the period. So just know that these two, they always increase down the group and decrease across the period. And to the last theory, which is the ionization energy, electron affinity, and electronegativity, just know that they decrease down the group and also increase across the period. So you can say ionization energy decrease down the group and ionization energy also increase across the period. So you can also say electron affinity decrease down the group and electron affinity also increase across the period. And lastly, you can say electronegativity decrease down the group and also increase across the period. So these are the major trends. So just know that these two, they are together and these three are together. So you can easily get it this way. So atomic radius, electropositivity increase down the group, decrease across the period. Ionization energy, electron affinity, electronegativity, they decrease down the group and increase across the period. So they are interchanging, but just know that these two are together and these three are together. So you can use the atomic radius and the electropositivity. So these two, they are together. And also ionization energy, which is IE, and we have the electron affinity, which is EA, and lastly we have the electronegativity, which is EN. So just know that these three are also together. So these three, they decrease down the group and increase across the period, and these two, they decrease across the period and increase down the group. So these are the major trends on the periodic table. And we also have some questions that might come out under this trend. They might ask you that what is the most electronegative element on the periodic table? So fluorine is the most electronegative element. So we have the fluorine as the most electronegative element. And the electropositive elements, we have cesium or rubidium. Some textbook might tell you that cesium is the most electropositive element on the periodic table, while some might tell you that rubidium is the most electropositive element on the periodic table. So either one of the two, the one you see in the option is correct. So the most electropositive element. So it is important to note all of this. You can say the most electronegative element on the periodic table is fluorine, while the most positive element or the most electropositive element on the periodic table is cesium or rubidium. So either one of the two is correct depending on the options. So let's look at some examples or some questions under the major traits of the periodic table. So the first question, as displayed on the screen, says that atomic radius increases A across the period, B down a group, C diagonally, and D nowhere. So looking at this trend, we said that the atomic radius increases down the group and decreases across the period. So either one of these two is correct. So let's look at what is correct in this option. So A says that across the period, and the question is asking that atomic radius increases A across the period. So it does not increase across the period, it decreases across the period. So option A is wrong. And B, atomic radius increases down a group. So atomic radius increases down the group. So option B is correct to this kind of question. Atomic radius increases down the group and decreases across a period. So option B is correct to this kind of question. So let's move to another question. Another question that we have says that ionization energy is the energy needed to A, add an electron, B, remove an electron, C, break a bond, D, form a nucleus. So to this question, from the definition of ionization energy, we said the ionization energy is the energy required to remove an electron from a gaseous atom. So to this kind of question, ionization energy is the energy needed to remove an electron. So option B is correct to this kind of question, because by definition we said it is the energy required to remove an electron. So option B is correct to this kind of question. So another question that we have says that the most electronegative element is A, chlorine, B, oxygen, C, fluorine, D, bromine. So from what we said earlier, we said fluorine is the most electronegative element in the periodic table. So option C is correct to this kind of question. So the most electronegative element is fluorine. So another question that we ask is that electron affinity is the energy change when an atom A lose an electron, B gains an electron, C share an electron, and D splits an electron. So let's look at the definition of electron affinity. We said by definition, electron affinity is the energy released when an atom gains an electron. So to this kind of question, electron affinity is the energy change when an atom gains an electron. So option B is correct to this kind of question. And another question that we have says that which group has the highest electron affinity? A group 1, B group 2, C group 17, and D group 18. So this kind of question, we said electron affinity is the energy released when an atom gains an electron. So this question is typically asking us that which group gains electron faster? So the group that gains electron faster are the group 7, so which are known as the group 17. So the group 7A, which are known as group 17, group 7A, they tend to gain electron faster because their ion is always -1. So that -1 means they are gaining electron. Their electronic configuration is mostly ending with 7. So they need one to balance up their electronic configuration to make the 8 octet true. So when they collect one electron, they become 8. So they are the group with the highest electron affinity because they always need one electron to make the octet configuration. So group 17, which is known as the group 7A, is the group with the highest electron affinity. So option C is correct to this kind of question. And we have another question which says ionization energy increases A down the group, B across a period, C from left to right, and D in noble gas only. So to this kind of question, let's look at the trend of the ionization energy. We said the ionization energy decreases down the group and increases across the period. So let's look at what is correct to this kind of question. So the question says ionization energy increases A down the group. So ionization energy does not increase down the group, it decreases down the group. So option A is wrong. And the second option, which is option B, says ionization energy increases B across the period. So ionization energy increases across the period. So option B is correct to this kind of question. And another question that we have says that electronegativity increases A down a group, B across a period, C only in group 1, and D in noble gas. So looking at the trend of electronegativity, so to this option, option B is correct because electronegativity increases across a period. So option B is correct to this kind of question, and option A is wrong because it does not increases down a group, it decreases down a group. So option B is correct to this kind of question. And another question that we have says that which trend decrease across a period? A electronegativity, B ionization energy, C atomic radius, and D electron affinity. So looking at this question, the question is asking us that which trend decreases across a period. So we can see that the atomic radius or electropositivity decreases across the period. So you can see you can find this theory there. You can find ionization energy there. You can find electron affinity in the option, and you can also find electronegativity in the option. So this theory then increases across the period, but atomic radius, which is the only odd option, decreases across a period. So which trend decreases across a period? The correct option to this question is option C, which is the atomic radius. So the atomic radius decreases across the period. So option C is correct to this kind of question. And that will be all on the trends of the periodic table. So let's move to the characteristics of metals, non-metals, and metalloids. So moving to the characteristics of metals, non-metals, and metalloids. So let's look at the characteristics of metals first. So looking at the characteristics of metals first, we can say they are found on the left side of the periodic table. So metals are found on the left side of the periodic table. So they are also good conductor. So metals are good conductors and they also lose electron to form a cation. So metals lose electron to form cation according to what we discussed earlier, and also they are mostly solid except mercury. So all metals are solid except mercury. Mercury is liquid at room temperature. So all metals are solid. And also they are malleable and ductile. So what this malleable and ductile means is that metals can be hammered into sheets and also metals can be drawn into wire. So this is the meaning of ductile and this is the meaning of malleable. So metals are malleable and ductile. And examples are sodium, magnesium, potassium, lithium, and so on. So we have and so on. So these are examples of metals and these are characteristics of metals. So they are found on the left side of the periodic table. They are good conductors. They are also loose electrons to form cation ions. They are always solid except mercury. They are malleable and ductile, which means they can be hammered into sheets and also they can be drawn into a tiny wire. And examples of metals are sodium, magnesium, potassium, lithium, and so on and so forth. So these are the characteristics of metals. So let's move to the characteristics of non-metals. So looking at the characteristics of non-metals, you can say they are found on the right hand side of the periodic table. So non-metals are found on the right hand side of the periodic table. And also they are poor conductor unlike metals. And also they are brittle when solid. So what this brittle mean is that they are easily broken. So this is what the brittle means. Brittle means that when non-metals are in solid form, they are easily broken. That's what this brittle is telling us about. And also they gain electron to form an ion. So non-metals gain electron to form an ion. So examples of non-metals are we have nitrogen, we have fluorine, we have oxygen, and we have fluorine, and so on. So these are the characteristics of non-metals. They are found on the right hand side of the periodic table. They are poor conductor unlike metals. They are brittle when solid, which means they are easily broken when solid. And they gain electrons to form an ion. And examples of non-metals are nitrogen, fluorine, oxygen, chlorine, and so on. So this will be all on non-metals. And lastly, let's look at the characteristics of metalloids. So under the characteristics of metalloids, they are found zigzag on the periodic table. So metalloids are found zigzag on the periodic table and also they possesses both metallic and non-metallic properties. And what this means is that they can act as both metals and non-metals. So this is what they are telling us about metalloid when they say they possesses both metallic and non-metallic properties. And lastly, examples of metalloids are boron, silicon, germanium, and so on. So these are examples of metalloids and this will be all about metalloids. So let's look at some examples or some questions under this aspect. The first question as displayed on the screen says that which element is a metalloid? A. Sodium, B. Silicon, C. Argon, D. Fluorine. So looking at this option, they said that the examples of metalloids are boron, silicon, germanium, and so on. So to this question, A, sodium, we can say A is wrong because sodium is a metal and not a metalloid. So option A is wrong. Option B, which is silicon, is correct because silicon is a metalloid. And option C, which is argon, argon is a noble gas. So option C is not correct. And option D, which is fluorine, fluorine is a non-metal as seen on the screen. So example of non-metals are nitrogen, fluorine, oxygen, and chlorine, and so on. So to this kind of question, Option B is correct because option B, which is silicon, is a metalloid. So option B is correct to this kind of question. Another question that we have says that metals generally form A negative ion, B positive ion, C noble gas, and D covalent bonds. From what we discussed earlier, we said metals form what? Positive ions, which means they lose electron to form a cation. So metals generally form a positive ion. So option B is correct to this kind of question. And the last question we have says that non-metal are generally A good conductors, B lustrous, C brittle, and D ductile. So from what we discussed earlier, we said non-metals are what? They are brittle when they are solid. So which means option C is correct to this kind of question. So non-metals are brittle, which means they are easily broken when they are solid. So option C is correct to this kind of question. And that will be all on metalloids, non-metals, and metals. And this will be all on the periodic table. Attempt this question on the screen and let me know your answer in the comment section. I will let you know if you are right or wrong. And if you found this video helpful, don't forget to give this video a thumbs up so more learners can find it. And don't forget to subscribe to Tech and EduSpark Hub, where technology meets education. And lastly, don't forget to turn on the notification bell so you won't miss any lesson or any updates from Tech and EduSpark Hub. And until next time, keep learning, keep coding, and I'll see you in the next one.